Read the tech press, and the narrative seems completely settled. The age of the human trucker is over. Autonomous software is supposedly ready to take the wheel and erase an entire global profession. The financial incentives driving this push are massive. Freight companies operate on razor-thin margins while battling constant driver fatigue, strict hours of service regulations, and a staggering turnover rate. An algorithm does not need to sleep at a rest stop or grab a cold coffee at 3 in the morning. But the idea that machines will seamlessly step in and run the entire industry relies on a deep misunderstanding. It treats truck driving as a single, simple action, just holding a steering wheel. To understand the actual future of this profession, we have to unbundle the job into its component parts. A trucker is a cargo inspector, a heavy equipment mechanic, a local dispatcher, a hazard evaluator, and a customer service representative, all rolled into one. Automation rarely replaces broad job titles. It targets and systematically replaces specific, predictable tasks. For AI, the ideal operating environment is known as the middle mile. Software thrives here because the rules are clear: long mapped lanes, consistent road geometry, and predictable physics. In these specific conditions, code performs flawlessly. An autonomous system can calculate exact cruising speeds, maximize fuel efficiency through smooth acceleration, and keep freight moving continuously without bumping into federal labor laws. That is why the first commercial rollouts are targeting highly structured logistics runs. The focus is squarely on moving freight between fixed hubs and major distribution centers. These fixed lanes attract billions in investment because they function as a controlled loop. Tech companies can map every inch of the asphalt, test their software repeatedly against the exact same variables, and exert complete operational control. If a worker's entire professional value comes strictly from steering straight down a quiet, repetitive highway, market demand for their specific skill set will shrink. But freight rarely stays neatly on the interstate. The system fractures the moment a truck exits the highway and enters the chaotic zones of the first and last miles. Here, pristine mapping ends and reality takes over. Before the tires even roll, someone has to physically secure the load. A human must climb under the trailer, evaluate the weight distribution of an awkward flatbed shipment, and torque down mechanical straps by hand. The complexity multiplies quickly. Hauling livestock or volatile hazardous materials means managing thousands of pounds of breathing, unpredictable variables that require constant, localized monitoring. Then you introduce environmental edge cases. When a heavy snowstorm hits, cameras and LiDAR sensors ice over, lane markings vanish. Pre-programmed operating rules break down, and safety relies entirely on a human's spatial intuition. Even on clear days, drivers navigate mundane hurdles that paralyze software. A delivery dock is blocked by 2 poorly parked vans. Physical paperwork goes missing at the receiving gate, or a yard manager suddenly alters a drop-off location based on unlisted weight restrictions. Code is rigid. The physical world is messy. The physical labor, constant improvisation, and human negotiation required to complete a delivery remain highly resistant to code. Developers correctly point out that an autonomous truck will never fall asleep at the wheel, check a text message, or drive impaired. Erasing those specific human errors directly remove major causes of highway fatalities. Yet replacing a tired driver with a computer introduces an entirely different category of systemic threats. A highly automated fleet becomes uniquely vulnerable to sudden sensor malfunctions, complex software failures, and active cybersecurity breaches. If a driverless truck crashes, liability initially points directly to the engineers who wrote the code, but that accountability fractures in reality. With poor maintenance, bad weather, and corrupted data, legal blame scatters into a chaotic web of competing liabilities. AI does not automatically erase highway risk. It trades the known dangers of human fatigue for technical liabilities, meaning these systems still require a massive layer of human oversight to function legally and safely. So, will algorithms replace the human trucker? The answer is partly, selectively, and unevenly. We are watching the industry permanently divide into 2 categories. Machines will increasingly consume the predictable, routine miles, while experienced professionals take over the complex, human judgment miles. A driver's daily routine will shift away from holding a steering wheel. They will spend more time managing strict administrative compliance, monitoring telematics data, and auditing digital safety systems on the fly. Entirely new technical roles are already emerging to support these operations. Experienced drivers are stepping out of the cab today to work as remote fleet monitors, complex yard operations coordinators, and autonomous compliance leads. The professionals who survive this transition won't be the ones pretending the technology isn't coming. They will be the ones who pivot to master the infrastructure surrounding it. This shift in trucking isn't an isolated case. It is a visible test for a pattern playing out across dozens of other industries. The logic remains the same. AI consumes the high-volume, repeatable tasks, but it consistently fails when it meets the messy, unmapped friction of the physical world. In a highly automated supply chain, a worker's value isn't defined by performing like a machine. Their true value lies in their complex problem-solving, their ability to negotiate with a dock manager, and their physical improvisation in a crisis. Ultimately, the professional advantage won't go to those who compete with the machines, but to those who master the uniquely human skills the machines leave behind.